Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here begins the essay. Guglielmo Marconi's endeavours in wireless telegraphy during 1895 represent a pivotal moment in the history of communication technology. This essay undertakes a critical evaluation of the claims, arguments, and experimental foundations laid down during that year, focusing on a granular dissection of the internal logic and evidentiary support deployed to establish this new form of communication. Preceding section this evaluation examines the specific claims made within Marconi's early work, interrogating the methodology and contextualizing the findings within the scientific landscape of the late 19th century. Section 1 Early experimental setup and claim of wireless signal transmission. Marconi's initial experiments centered around the premise that electromagnetic waves, theoretically predicted by James Clerk Maxwell and experimentally demonstrated by Heinrich Hertz, could be harnessed for signaling purposes without the necessity of wires. His claim, radical for the time, asserted the possibility of transmitting and receiving signals across significant distances through what was then understood as an ethereal medium. An evaluation of this initial claim hinges on an understanding of his apparatus. It consisted primarily of a Hertzian oscillator, modified to generate radio frequency signals, coupled with a coherer, a device invented by Edouard Branly, which acted as a sensitive detector of electromagnetic radiation. The coherer, essentially a glass tube filled with metallic filings, exhibited a change in electrical resistance when exposed to radio waves, allowing for the detection of signals. Marconi's initial setup involved varying the distance between the transmitter and receiver, carefully observing the coherer's response to determine the range of wireless transmission. This process, while rudimentary by modern standards, established a foundation for subsequent refinements. The validity of Marconi's claim at this stage rested heavily on the reliability and sensitivity of the coherer, which was known to be somewhat temperamental and susceptible to extraneous electrical disturbances. Careful shielding and grounding techniques were essential to isolate the desired signal from background noise, a challenge that Marconi addressed with considerable ingenuity for the available technology. Section 2 Improvements in range and the grounding technique. A crucial advancement in Marconi's experiments involved the implementation of grounding techniques, wherein both the transmitter and receiver were connected to the earth. This innovation significantly enhanced the range of signal transmission. His claim that grounding improved signal propagation relied on the principle that the earth could act as a conductive medium, allowing electromagnetic waves to travel farther than they would through air alone. Evaluation of this claim requires an assessment of the underlying physics. Grounding the antenna effectively increased its electrical length, improving its efficiency as a radiator of electromagnetic energy. Furthermore, the Earth's conductivity, while not perfect, provided a low-resistance path for the return current, completing the electrical circuit and minimizing signal attenuation. Marconi meticulously documented the increased transmission distances achieved through grounding, comparing performance with and without this technique. The data presented strong empirical support for his claim, although a complete theoretical understanding of the underlying mechanisms would require further investigation into the properties of ground conductivity and wave propagation over the Earth's surface. It is important to note that, at this point, the prevailing understanding of radio wave propagation was incomplete, relying heavily on empirical observations and experimental validation. Section 3 The use of elevated antennas and further range enhancements. Seeking to extend the range of wireless communication further, Marconi introduced the use of elevated antennas, suspended high above the ground. His claim posited that elevating the antenna would increase its effective radiated power and improve signal transmission over longer distances. This claim aligns with fundamental principles of antenna theory. An elevated antenna experiences reduced ground losses and increased radiation efficiency compared to an antenna placed closer to the Earth. The higher vantage point also minimizes obstructions and allows for a clearer line of sight between the transmitter and receiver, reducing signal attenuation. Due to obstacles in the propagation path, careful experiments were conducted to quantify the relationship between antenna height and transmission range. Marconi systematically varied the height of the antenna and recorded the corresponding changes in signal strength at the receiver. These measurements provided compelling evidence supporting the claim that elevated antennas significantly improved the performance of wireless communication systems. While a rigorous mathematical analysis of antenna radiation patterns was not yet fully developed at the time, Marconi's empirical observations provided valuable insights into the practical benefits of elevated and Section 4 development of the covera and signal detection. Marconi focused intensely on enhancing the sensitivity and reliability of the covera, the crucial component responsible for detecting incoming radio signals. His assertions centered on achieving more consistent and dependable signal detection, crucial for practical wireless communication. The covera's operation depended on the principle that radio waves could cause the metallic filings within the tube to clump together, reducing the electrical resistance and allowing current to flow. However, the covera was prone to false triggering and required a mechanical tapper to restore it to its original sensitive state after each signal detection. Marconi's innovations included experimenting with different types of metallic filings, varying the dimensions of the tube, and optimizing the mechanical tapper mechanism. Through systematic experimentation, he identified configurations that yielded improved sensitivity, reduced false triggering, and more reliable operation. Furthermore, he developed techniques for shielding the covera from unwanted electrical interference, further enhancing its performance in noisy environments. The improvements in covera design and signal detection were critical for extending the range and reliability of wireless communication. Section 5 Refining the Morse code transmission. Marconi adapted the existing Morse code system for wireless transmission, enabling the encoding and decoding of textual messages. His argument centered on the practicality of employing a standardized code for communicating information using the newly developed wireless technology. The Morse code, consisting of dots and dashes representing alphanumeric characters, provided a simple and effective method for encoding messages. Marconi's adaptation involved using a key to interrupt the radio signal, generating short and long pulses corresponding to dots and dashes. At the receiving end, the covera detected these pulses, and an operator could then translate them back into textual information. The elegance of this approach lay in its simplicity and compatibility with existing telegraphic infrastructure. The implementation of Morse code provided a practical demonstration of the potential for wireless communication to transmit meaningful information over long distances. It also highlighted the importance of standardization in communication protocols, ensuring interoperability between different wireless systems. While not a novel invention in itself, the integration of Morse code into wireless telegraphy was a crucial step in transforming it from a scientific curiosity into a practical communication tool. Section 6 Overcoming Obstacles and the Diffraction Phenomenon. Marconi observed that radio signals were capable of traversing obstacles, such as hills and buildings, even when a direct line of sight between the transmitter and receiver was absent. His claim centered on the phenomenon of diffraction, whereby radio waves bend around obstacles, allowing them to propagate beyond the horizon. An evaluation of this claim requires understanding the wave nature of electromagnetic radiation. According to wave theory, when a wave encounters an obstacle, it bends or diffracts around the edges of the obstacle. Diffraction allows radio waves to propagate into areas that would otherwise be shadowed by obstructions. The extent of diffraction depends on the wavelength of the radio waves and the size of the obstacle. Longer wavelengths tend to diffract more readily than shorter wavelengths, allowing them to bend around larger obstacles. The frequencies employed by Marconi in his early experiments were relatively low, resulting in longer wavelengths that exhibited significant diffraction effects. While Marconi may not have possessed a complete theoretical understanding of diffraction at the time, his empirical observations provided compelling evidence of its importance in wireless communication. This discovery suggested that wireless communication was not limited to line-of-sight paths, opening up possibilities for transmitting signals over significantly longer distances and around geographical obstructions. Section 7 Cross-channel communication demonstrations and maritime applications. Marconi conducted several public demonstrations of wireless communication, including successful transmissions across the English Channel. These demonstrations served to validate his claims and to showcase the potential of wireless telegraphy for maritime applications. His argument focused on the capacity of wireless communication to provide a vital link between ships at sea and land-based stations, improving safety and enabling more efficient navigation. The ability to communicate wirelessly across significant bodies of water had profound implications for maritime industries. It allowed ships to report their position, request assistance in emergencies, and receive weather updates from shore-based stations. This enhanced communication capability significantly improved the safety of maritime travel and reduced the risk of accidents. Marconi capitalized on these benefits, actively promoting the use of wireless telegraphy for maritime applications. He established wireless stations along coastlines and equipped ships with wireless equipment, creating a network that facilitated communication between ship and shore. The success of these deployments further validated the claims surrounding the practicality and reliability of wireless communication. Section 8 Addressing Skepticism and Scientific Community Reception. Marconi's work faced considerable skepticism from some members of the scientific community, concerned about the novelty and potential limitations of wireless telegraphy. His response involved emphasizing the empirical evidence, demonstrating the repeatability of his experiments, and refining the underlying theory to address concerns. Skeptics questioned the reliability of the coherer, the range limitations of wireless transmission, and the potential for interference between different wireless systems. Marconi addressed these concerns by conducting rigorous experiments, documenting his results thoroughly, and publishing his findings in scientific journals. He demonstrated the repeatability of his experiments under controlled conditions, providing compelling evidence of the reliability of his technology. He also worked to improve the selectivity of his receivers, reducing the susceptibility to interference from other sources. Furthermore, he collaborated with prominent scientists and engineers to refine the theoretical understanding of radio wave propagation, providing a more solid scientific foundation for his claims. Through a combination of empirical validation, theoretical refinement, and public demonstrations, Marconi gradually won over the scientific community and established wireless telegraphy as a viable and promising technology. He adopted a pragmatic approach, focusing on practical applications and demonstrating the real-world benefits of his system. Section 9 Patents and Intellectual Property Considerations. Marconi secured several patents for his inventions related to wireless telegraphy, protecting his intellectual property and establishing a foundation for commercial exploitation. His claims centered on the originality and inventiveness of his designs, asserting his right to control the manufacture and use of his technology. The securing of patents was a crucial step in transforming wireless telegraphy from a scientific curiosity into a commercial enterprise. Patents provided Marconi with exclusive rights to his inventions, preventing others from copying or profiting from his work without his permission. This intellectual property protection allowed him to attract investment, establish manufacturing facilities, and build a business empire around wireless communication. The patents covered various aspects of his invention, including the design of the coherer, the grounding techniques, and the methods for modulating and demodulating radio signals. These patents provided a legal framework for controlling the use and development of wireless telegraphy, shaping the trajectory of the industry for decades to come. It is important to note that the validity and scope of some of Marconi's patents were later challenged in court, leading to legal battles and debates about the originality of his inventions. However, the initial patents played a pivotal role in establishing his position as a pioneer and innovator in wireless communication. Section 10. The broader context of scientific advancements. Marconi's work was deeply interwoven with other developments in physics and electrical engineering of the late 19th century, while highlighting his particular advances through his experimental apparatus. It is important to note that his claims were deeply connected to the burgeoning field and understanding of electromagnetism. His work was built upon the theoretical foundations laid by James Clerk Maxwell, whose equations mathematically described the nature of electromagnetic waves. Additionally, his experiments relied on the experimental work of Heinrich Hertz, who first demonstrated the existence of radio waves. Furthermore, the development of wireless telegraphy was closely intertwined with the growth of the electrical industry. The availability of reliable sources of electricity, such as dynamos and batteries, was essential for powering the transmitters and receivers used in wireless communication. Advances in electrical engineering, such as the development of improved insulators and conductors, also contributed to the performance of wireless systems. This period was characterized by a rapid pace of technical innovation, with breakthroughs in various fields contributing to the development of new technologies. Marconi's success was rooted in his ability to integrate these diverse technological advancements into a coherent and practical system for wireless communication. He synthesized existing knowledge and experimental techniques into a novel configuration, demonstrating the power of interdisciplinary collaboration and innovation. Section 11. Limitations and acknowledgement of error. While Marconi's 1895 endeavours were seminal, they possessed inherent limitations and admitted certain unavoidable errors. His acknowledgments of these limitations contributed to the robustness and credibility of his overall framework. His recognition of these limitations reflected an understanding of the challenges involved in developing a new technology and a commitment to continuous improvement. One limitation was the relatively short range of early wireless transmissions. The distances achievable with Marconi's apparatus were limited by the power of the transmitters, the sensitivity of the receivers, and the effects of atmospheric attenuation. He acknowledged that further improvements in these areas were necessary to extend the range of wireless communication. Another limitation was the susceptibility of wireless systems to interference. Radio signals could be disrupted by natural phenomena, such as lightning, or by man-made sources of electromagnetic radiation. Marconi recognized the need for improved filtering and shielding techniques to mitigate the effects of interference. Furthermore, he acknowledged that the theoretical understanding of radio wave propagation was incomplete. The complex interaction of radio waves with the Earth's atmosphere and terrain was not fully understood, making it difficult to predict the performance of wireless systems in different environments. Addressing these limitations required continued research and development, paving the way for future advances in wireless technology. Section 12. Enduring significance and legacy. Despite certain limitations, Marconi's work in 1895 established the fundamental principles of wireless telegraphy, laying the foundation for a revolution in communication technology. His initial claims, grounded in empirical observation and supplemented by the latest theoretical understanding, have proven remarkably prescient. This legacy of his is evident in the widespread adoption of wireless communication technologies today, from radio and television to mobile phones and satellite communication systems. The impact of wireless communication on society has been profound, transforming the way people live, work, and interact. Wireless technology has enabled instant communication across vast distances, facilitating global trade, fostering cultural exchange, and connecting people in remote and underserved areas. Marconi's pioneering work in wireless telegraphy has had a lasting impact on the world. shaping the course of technological innovation and transforming the way we communicate. His dedication to experimentation, his commitment to innovation, and his ability to translate scientific discoveries into practical applications have inspired generations of scientists, engineers, and entrepreneurs. He demonstrated the transformative potential of technology to address societal challenges and to improve the quality of life for people around the world. His ability to recognize the transformative potential of wireless communication, coupled with his relentless pursuit of innovation, cemented his place as a technological visionary. In conclusion, the claims made within Marconi's 1895 work on wireless telegraphy, when subjected to rigorous evaluation, reveal a remarkable blend of insightful experimentation and astute application of evolving scientific understanding. While certain claims were limited by the nascent state of radio science and technology, Marconi's systematic approach, persistent refinement of apparatus, and shrewd recognition of practical applications validated his core assertions. His legacy, firmly rooted in these early endeavours, continues to resonate throughout the modern world, testament to the enduring power of scientific inquiry and technological innovation. The thorough examination of the underlying mechanisms, experimental evidence, and societal implications affirms the transformative power of the technology.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.